Welcome to Module 4 of the CDOT Utilities Process Management course. We're now going to move into the 30 to 90% design phase of a project. With 0 to 30% design phase completed, the utility engineering process continues into the 30 to 90% design phase. We'll start by exploring the quality level A investigation, which builds upon the information that was gathered during the quality level D, C, and B investigations. The quality level A investigation is absolutely dependent upon the quality of the previous information and investigation. Quality level A, also known as locating, according to ASC 38 standards, using non-destructive excavating equipment at critical points to determine the precise horizontal and vertical position, type, size, condition, material, and other characteristics of underground utilities. Physically exposing those utilities, and locating, or location, is vertically and horizontally tied to the project datum. That's extremely important. We have to be able to relate it back to the project survey information. And Joe mentioned early on in kind of the planning, SUE planning phase earlier in modules, one of the earlier modules, I guess, emphasized when you're engaging a SUE company that information should be transferred over to them early on so that they know what they need to tie the project to as they're kind of proposing and scoping the project, so they have an understanding of where the control points are and everything like that. And then, the pictures on the right are just examples of test holing and locating those utilities and then patching them back, and then some of the measure down cards that they have. So there's different ways to go about it. Each SUE vendor tackles it a little bit differently, but ultimately the end output is the daylighting the utilities and having good information on where they are vertically. And again, down at the bottom, you'll see that this is a SUE function. Utility coordination is not part of this this piece in our process. We have two types of utility plan sheets that we want you to be aware of. Type 1 plan sheet is a SUE plan sheet stamped by the consultant, the SUE consultant, PE, as a standalone sheet with the existing conditions. And this may or may not be provided within a construction plan set. It may be provided as a separate for information only document. It may be also inserted into a construction plan set as for information, but just be aware this is not typically anything more than just information for a contractor, and so how it's presented to the contractors is maybe a little bit different, but still it's just information for them. And for development of the actual type 2 plan, which is the utility plan set, this is the plan set that you would see in a construction plan set going out to a contractor. And again, what we've shown on previous modules for utility, region utility, program managers and designers to leverage also with utility coordination, using this plan sheet as well to convey information back and forth between utility companies and designers and utility program managers. So you'll see that SUE is really, utility coordination in SUE is on this slide, and the left deliverable to type 1 is primarily SUE, and then utility coordination leverages the type 2 plan set from there. And so that's really what we're trying to convey in this slide, that there is there's two types of utility sheets, the SU plan and then the utility plan. So sample engineer notes on construction plans is something that we wanted to detail because that's a little bit new to our group as well when it comes to SU plans, and then whether or not the SU vendors should be putting these notes on their plans. We just want to make sure that they're there somewhere. And so you would typically see this is a standard note based on the ASC 38 standards, where the utilities are depicted on these plans in accordance with their achieved quality levels as defined in the American Society of Civil Engineers document ASC 38. So again, that's the standard guideline for the collection and depiction of existing subsurface utility data. And then it goes on, to state the reliance upon this data for risk management purposes during bidding, that kind of stuff, but it doesn't alleviate the contractor of their due diligence, and they're still required, to complete their investigations based on, in our case, state statute says the contractors have to do their own locates, call them in, things like that. So there's separate things going on here, but it's intended to just emphasize the fact of the SU investigation and how it's a standalone piece, and that the excavation is also a standalone piece. So I just want to make sure that's clear, that contractors still must complete their investigations based on the requirements under the excavation portion of the law. So utility plan and proposed test holes, this is, something, again, we're talking 30 to 90%. So this is right around that 30 to 40% design level action item, and as close to post FIR as possible is where we resolve any of the design requirements coming out of 30%, really starting to focus in on the true conflict areas that we want to investigate via test holes. And so this is a plan sheet that has moved from a utility plan to now a proposed test hole plan sheet. And so the proposed test holes you'll see in little circles there, kind of a purple color, but those are identifying those gas line conflicts that are labeled G dash whatever number, and SA is sanitary. And so it's a tool to cross-reference those call-outs, are just a tool to cross-reference the conflict matrix. Again, we'll show the conflict matrix here and how that data is expanded from the graphic side of this package to the actual tabular information that's involved in there, included in the conflict matrix. So, the proposed test holes is then a SU function that's passed along via the utility coordination team. It's been resolved, and then the SU vendor is brought back in to then actually go out in the field and conduct the quality level A investigation as previously discussed.
And in the slide, you'll note, obviously not every proposed conflict has a need for a test hole. An example of that may be sanitary 5 or sanitary 6, the brown SA5, SA6. Since we can pick up the inverts of the pipe, we can interpret where the top of pipe is and identify the conflict without the need for a test hole. So with data that we can collect previously in our QLB plan, eliminates the need for QLA in those two situations, where we don't have that information for, say, for instance, a gas line G12, G13, G14. We need to go in and test hole and identify top of pipe on that high pressure gas line. So some of the things that you're noticing here, certainly not every point demands a test hole.
Yeah, no, that's an excellent point. In fact, if you look at what is it, probably water line call out 29, W29.
Mm-hmm.
We know that that's a conflict with that, with that storm drain line, but the city, I believe, had plans to maybe relocate that anyway. And so really the effort was, let's not identify it to test hole it, but let's just make sure when they install it, it's low enough that our storm drain lines can come in over the top of it.
Right, and it's through utility coordination, the marriage between utility coordination and the SUE plan, that we're able to identify the conflict. We've met with the city and said, here's your conflict at W29. City says, don't worry about it. You don't have to test hole in that location because we're going to move it anyway. And it was really those utility coordination efforts that led us to this point where we do not have to test hole.
Yeah. So
building blocks to where we are today.
Exactly. Excellent. And then again, as we move from the test hole information, the SUE company gathering that field verified data, it's then brought into this utility conflict matrix. This is an example of that project. And then as you recall, some of the call outs on the previous slide, like G3 or G9 or G10, I guess on this particular slide, or G11, and maybe even more particular G12 has some really good information about it.
Yeah, so for this particular project, G12 was really significant and became more and more significant as we recognized that we had conflicts with a high pressure gas line. Not only did it tell us that initially in our utility coordination that we had a conflict and there might, in that location, it also actually told us, it helped us identify safety critical work for the project, because as we know that we have a 14-inch section that's going to be reconstructed over the top of this, when you take 14 inches off that 3-foot measure down, you've got a high pressure gas line that's doesn't have 2 feet of cover over it. So the loading requirements, potentially the compaction requirements over the top of that need to be identified as safety critical work, where the contractor can store vehicles in adjacent to that line, or where it crosses that gas line, how we protect that line during, or how the contractor protects that line during construction. Having that measured down and that data here led to identification of other issues further along in the project. So it's really good to have this matrix and identify that safety critical work.
Yeah, that's a great example, Joe. I think it shows how SUE, which is the gathering the elevations, measure downs, and then the utility coordination piece really coexist in this matrix, as far as then taking that data, identifying it's a safety critical item. I need to contact the utility company. We need to work on relocation of a 12-inch steel gas line because of this issue, and so.
Well, we can really highlight that for the contractor in the spec. And when we provide a revision of that section and say, look, safety critical work, we know we've got a high pressure gas line. This is a watch out condition for you. It really is a good marriage between all those things. And hopefully it helps us avoid a pretty, potentially a very serious accident.
Oh, absolutely. And one of the items that we leverage all this information from that utility conflict matrix is also a handout for everyone, which is labeled as Module 4, Handout 1, Work Plan Template. This work plan is really critical to review and prioritize actions with utility companies and discuss relocations, detail the scope of the work, who pays for the relocation, construction and related timelines, including deadlines. So when you look at Joe's example, if you take this work plan, we're working with the gas company, we know what the real conflict is, and so now we're talking about a relocation. to relocation. The scope of the work is a 12-inch steel gas line. It needs to go lower, deeper, and stay away from, you know, new items that we're going to install. How long is it going to take? You know, you guys need 6 months of construction. You need 6 weeks, 6 days. It just kind of depends, right? So this work plan is intended to really walk through that with the utility company. You know, some of this information we may already have in our draft spec as far as utility contact information, but maybe it's multiple people we need to identify. Maybe it's the engineer that we have on here, and then we need a construction manager also identified, because once they design it and hand it off to construction, we want to have that also. So we're starting to get into really the details of the relocation, who is going to pay for it, the estimates, if it's eligible for cost reimbursement. Of course, we really need to start getting estimates from the utility companies based on this conflict analysis and their redesign and relocation plans. We need that independent cost estimate filled out, and we have examples of what we expect on that side of it. We'll show here in a little bit for contracting purposes. And so, yeah, we're leveraging a lot of data from the plan sheets, the conflict matrix example, and pulling that into this work plan. But at the end of the day, the utility coordination side is using this to document everything, the expectations, the roles, responsibilities, and ultimately this could be used as a non-compensable agreement, you know, as far as that goes, because the intent is to have everybody sign off on it at the end of the day, so that we all understand the expectations moving forward from here.
And it helps you develop your spec as well.
And it does. It helps finalize that spec, and that's a good point, Joe. That, you know, this is just a continuation from the draft, and then we're really honing in on what the final details are for the final spec. So as we move through this 30 to 90%, we've gathered a lot of information based on 30% design. It's continuing into 60%, 90% design. We've identified conflicts based on quality level A information, a conflict matrix. We've developed our work plan, the expectations of the relocations. If we have something that relocation that requires cost paid out to a utility company, we have agreements for that. If we identify a utility that is in a condition where maybe it needs replaced, but it's not eligible, but somebody wants to maybe include that in the contractor's work, we have a contract for that, and I'll talk about that here in just a second. But some of these other contracts that we look at, utility franchise agreements with cities, counties, and the utility companies are important to know about. There is some eligible costs that are accumulated over time with some of the utility companies that can be leveraged to pay for like street lighting and other stuff, improvements, sometimes overhead utilities going to underground, especially power. You can sometimes use franchise agreements and funding that's then set aside through these franchise agreements to pay for some of that or offset some of the cost. URAs, or utility relocation agreements, are a design build agreement that we've used in the past to establish pre-RFP type expectations with the utility companies. And those are executed so that when the contractors come on board and take off with their design build portion, they have a commitment by the utility companies to work with the contractors to develop and move utilities through this URA. And it's something we've used historically on design build only. Again, ICC, or incurred cost contracts, basically the utility pays CDOT, and that could be a municipality that owns a utility. It could be a utility company that owns facilities. I have had many projects where we found it to be in CDOT's best interest to include this work, utility work, in our project so that we have control of the schedule of when this stuff is installed. We have control of the contractor who's installing it. So it makes a lot of sense in that realm that we leverage this contract sometimes to bring money from the utility that is looking to upgrade something or replace something under our roadway that really is a good idea for the agency to include. So that's a mechanism that we've used, and it works well. And then the standard utility agreement is when we're scheduled to pay utility companies for eligible relocation costs, which include design, construction, and inspection and as-builting of their facilities. And so typically this SUA is executed with the understanding the utility company will move forward with the relocation of their facilities with their own contractor, and they will take care of that, and we'll just pay them for the relocation. We use this agreement a lot with early relocations that are eligible, and we've also used it for relocations that happen during construction as well. Again, it's just the mechanism to pay the utilities back for their moves that are eligible under the rules. And so irrigation companies, we have a lot of irrigation crossings throughout the state. So we'll use a standard utility agreement to pay irrigation companies. And for some stuff, we do have an irrigation agreement that's really more, it's not for exchanging of funds. It is for notice to the irrigation company about a change in their facility. Maybe it's the size, maybe it's the length, maybe it's going from an overhead irrigation crossing to an underground siphon type of situation. So it's used to, again, get their concurrence to allow our contractor to replace something that's out there now with something different. Is usually the concurrence. And again, this is typically all utility coordination type level effort as far as these agreements and talking and speaking with all these utility companies and kind of getting the estimates ready and things like that, and then routing these through the proper channels for execution internally at CDOT. Same with railroad. We have some railroad agreements that we want to make you aware of. We have construction maintenance agreements. We have maintenance consent letters. We have drainage encroachments permits for any new drainage facility, like a CDOT project that has crossing of the railroad with a new drainage pipe. That's a standalone encroachment permit or utility permit. Same thing with electrical or ITS fiber lines or CDOTs. They have what's called a wireline permit. So drainage and wireline permits are common with our projects with the railroad, so just keep those in mind. And then lease agreements for real estate. We have lease, we have purchases and things like that for permanent easements and things that go along with railroad as well. And then, of course, non-reimbursable relocation agreements, which we consider more of that work plan. This is an FHWA requirement that we have an agreement in place for every utility on a project, whether it's compensable or not. So whether it's reimbursable or not. So that's where that work plan is a good mechanism to capture the relocation plan and an agreement of schedule and resources and things that are needed for relocation. During a Federal Highway Administration audit, they noticed that there was a lot of deficiencies in identifying all the roles and responsibilities for non-reimbursable agreements. So that's kind of where this comes from, and that's what our work plan is intended to resolve. So agreement cost estimates. These are exhibits to previously mentioned contracts from the previous slide. So as part of our handout package, Module 4, handout number 2, labeled Utility Agreement Estimate is provided for those that want to take a deeper dive into this cost estimate. It is available, and what I like most about this agreement, and you'll notice if you take time to look through it, there's a lot of code of federal regulation references within this estimate that will help guide you through why things are being requested at certain sections of this estimate. And, so the minimum amount of information that we need to provide to satisfy the CFRs. So it's a very good tool to make sure we're covering our bases when it comes to estimating a project that's eligible for relocation. And again, the eligible relocation and reimbursement items are design, relocation, inspection, and construction management, and also as-built drawings. And, the intent, again, here is to use a standardized form. This is something that all of our region utility program managers will leverage for consistency's sake, and that helps with the Federal Highway Administration audits as well when they come in and ask to review our projects. Again, this is a utility coordination effort, as most of you can see. So as we approach the end of our 30 to 90% phase, we're finalizing these agreements with the providers. So we've worked through early on in the work plan, we've identified who pays, and when does payment occur is something that we start to look at as far as budgeting and utility phase budgeting, because it may be that there's an early relocation, we have this early agreement that we need to execute, so we need to make sure that we're conveying early enough to business managers and program engineers and resident engineers what those utility phase budgets are needing in order to execute these contracts, which helps finalizing those relocation plans, the budget, like I said, and finalizing that specification. As we get to 90%, we want all this stuff really coming together for the final office review or FOR milestone. And about that time, we could be issuing utility permits for early relocations and
setting up U phase.
Yeah, U phase, budget finalized for relocation. That's the U phase request, and notifications and agreements from the work plan and any other agreements that we have pending are starting to finalize through the utility coordination effort at this point. We get a lot of questions around when do you relocate utilities? When is the proper time? And of course, it kind of depends. It depends on where we've come through the entire process up to this point. It starts to really identify the early relocations when we're in that conflict matrix resolution. We're starting, we built that work plan a little bit earlier in this module. It should really start to show where in the schedule, from the construction schedule for the overall project to where we need to start looking at construction schedule for the utilities. And so, for example, I'll use Grand Avenue Bridge that's shown on the screen in the picture in Glenwood Springs. This particular project had multiple utility relocations, and as we worked through the process of identifying all the conflicts and then identifying through the work plan how long it was going to take to move, in particular with the gas line facility that crossed over the river, crossed over I-70 that you can see in the picture, and also crossed over the railroad tracks on the old viaduct, the old bridge that was out there. It's not in this picture, but the gas line connected on the north side and the south side, ran across, and that we had to basically completely dismantle the gas line in two phases, because we had a phase one that built the pedestrian bridge that you can see in here, and we had a phase two that built the traffic bridge that you see in this picture, and also demoed the old traffic bridge. But the point of this is, with an early relocation that we pursued with the gas company, they needed a long enough lead time to relocate the gas lines in the downtown area that are in the streets in order to arrange them in a configuration so that they could tie into the phase one pedestrian bridge construction. And so their effort, the first early construction season for utilities was a whole year before we actually started construction on that pedestrian bridge. But the gas company came in, they relocated under, some of it was under a standard utility agreement to relocate some of their utilities, some wasn't. But the point is they moved a bunch of gas lines in anticipation of the first construction season for the pedestrian bridge, so that they were ready to go and they were out of the way for our contractor to come in and work on that first phase of the pedestrian bridge. If the gas company had waited to start when our construction contractor started, they would have been on top of each other, and there would have been conflicts in the downtown area, in the streets, where new storm drain lines needed to be put in while they were building this bridge, and a lot of phasing discussions at 30 and 60% design with the utility company and our designers and everybody else about phasing and pursuing an early relocation for a portion of the gas line versus just starting all at the same time and trying to work around each other was certainly something that was identified and pursued early on. And I say early on because the gas company was moving their gas lines while we were still at 90% design. But we ultimately knew where things needed to go by the time the contractor showed up. So that's an example. And then the remaining gas line cutovers happen during construction. So there's times when the utilities relocate early and they relocate everything early. There's times when the utility companies relocate a portion early, and then the remaining relocation happens during construction. And there's many reasons behind that, and a lot of it's due to impact to businesses and traffic and traveling public, to where we don't go in and tear up the road twice. We just take the opportunity while the contractor's in there to finish the relocation. And then there's cases where it's purely 100% relocation effort during construction. And that's something, again, that really needs to be identified 30 to 60% design, where we're trying to understand how the phasing for CDOT's project and the phasing effort for the utilities, really work together in order to achieve the most efficient project. So, Joe, any comments on that?
No, I can't reiterate enough how important it is to relocate prior to construction. It just helps all facets of construction. If we can have our providers out of the way, we've already identified conflicts throughout the process, have the utilities there. Anytime we can eliminate a third-party entity that's in our construction site doing work, it just creates schedule conflicts and other types of conflicts. So really want to get those done. And like you said, Rob, there's just sometimes when you can't, when you have to either accept the work as our own and do it under a ICC, or there's just many different ways to approach this. But
Yeah, I think, and that's a great message. I mean, if anything else, I just want everybody to start thinking a little earlier about the phasing of the utility construction, and not just assume that it all should happen about the same time that our contractor shows up to work. Is there an opportunity for early relocates? If so, then let's try to do that. If there's not, then we'll include it in the work or identify it and give contractors notice and put it everywhere we can, so that as a contractor coming into the project, they have the opportunity to know what the risk is from a utility standpoint and what they have to deal with, like you said, with third parties working on top of them. There's a lot of effort that has to go in with multiple contractors on top of each other. There's traffic control issues, there's stormwater quality issues when you have utility contractors working on top of the CDOT contractors. So a lot to consider. If you can have them segregated out, it's great. If you can't, some of the urban areas, Denver, it's just almost impossible to do an early relocation. So you really have to coordinate well with the construction specs and plans to make sure that there is good information for the contractors to understand what their commitment is to making that piece work during construction.
Right, and all the way back in the planning phase of this process, we've reached out to utility companies and said this project is coming. We're going to go through and we've gotten their data, we've identified what's in the field, we've asked them for opportunities to comment. As we step through, we've showed them our potential conflicts, what we're intending to do, and we've worked through the work plan that you talked about. We've built specs, we've gone back and then test hold, and so it's a long, iterative process working with the utility provider up to this point. So they've hopefully had ample notice that this is coming. They hopefully have that opportunity to relocate early because they recognize the conflicts that it would avoid. And you've got a documented record of how many times you've connected with a utility company in the past. Hopefully you've got agenda and follow-up notes and minutes from the meeting, what was discussed. So you've got you can approach them at the end of the project or right when you're into your design phase, right where you're going to construct, and say, we're ready for you to move. This shouldn't be a surprise to you. So all those building blocks to utility coordination that culminate in getting things moved and out of your way.
Absolutely. Yeah. No, those are good points and critical points. So just continuing on with who relocates utilities. If utilities must be moved during the project, who will move them? Is it the utility owner or the contractor? We touched on this a little bit. And so when we look at alternative delivery at CDOT, we have a couple of different ones. We have construction management general contractor, also known as CMGC. Design bid build is not alternative, but that's our traditional way of delivering our projects. But the point of this is the CMGC mimics the design bid build process more than design build does. And so under design bid build, the only real difference is the guesswork. It goes into the proposed phasing and the work with the contractor on an appropriate phasing plan. So what that means is you don't always know how the design bid build contractor is going to approach phasing until they actually see the plans, bid on it, and obtain notice to proceed on the project. Then they really hammer out their phasing plan. And so this becomes a little bit of a moving target for utilities, because you're like, well, I think they're going to phase this first. I hope they do, because if they do, then this phasing of the utilities would work. But if they come in and they change it and they want to phase something that's not, that we haven't identified as a first, then we're in a critical path as far as schedule goes already, because then the utilities may may be in conflict right out of the gate, and we're scrambling to get things moved just because we're not sure. And so one of the ways we can tackle this from a design bid build scenario is to have conversations with the contractors at a mandatory pre-bid meeting. So if it's a larger design bid build project, and you know you have some high-risk utilities, and you know you have some phasing that you've worked out with the utilities through the entire work plan process, and all the utility coordination's gone on up to this point, then sit down with the contractors that are planning to bid on a project and walk through that with them. I had a project up in south of Kremling on State Highway 9, where we were 10 miles of game passes, wildlife game passes, where we needed to move 10 miles of phone, fiber, and power, and things like that. And so we knew it was going to be difficult to move 10 miles of utilities prior to the start of this project. And so we had, and this was design bid build, and we had decided with the utility companies if we could move the first 5 miles before construction started, identify that in the plans, identify in the specs, and then have the contractor come in, build the first 5 miles while the first season, and during that first season have the second 5 miles move those utilities, because we knew it was a 2 construction season project anyway, that we could kind of leapfrog the utility relocations and provide 5 miles and 5 miles at a time for the contractor to do the work. And so we had a mandatory pre-bid with all the contractors that came in, and they listened to our phasing plan. We had a lot of contractors that said, we would have never considered that. We would have just considered opening up all 10 miles, replacing all the culverts and putting in the deep foundation stuff and all that in the 10-mile corridor, if you hadn't given us pre-bid notice and of your phasing plan. So ultimately, the contractor that won the bid went with our proposed phasing plan with the 5 miles first season, 5 miles second season. And I think, the way they bid it is knowing that they could bank on the fact that they'd have a clear 5 miles rather than a really kind of clouded, not sure if I'd have a full 10 miles to work in scenario. So that's the benefit of a mandatory pre-bid meeting for utilities that are high risk and need to really be focused on and showcased to those bidders. But then when you look at CMGC, you get all the benefits of working with a contractor during the design and phasing of the utilities from an early stage of the design. And so you have a contractor working with your design team, working with your utility coordination team, even maybe working with the SUE team for quality level A test holes if needed, because they could identify some things that during design, during the construction phasing and reviews, the contractors are providing that construction input and during the building of the design plans. And so there's a lot of benefit to extremely difficult projects, utility projects within these overarching CDOT projects. And Grand Avenue Bridge was a CMGC project, and it definitely benefited from having the contractor at the table working with us to develop phasing plans and how they were going to construct certain types of walls and bridges and things that are typically unknown during design bid build scenario. And then when we look at design build, we're looking at a couple of things. We would like to see SUE, subsurface utility engineering, completed from 0 to 10% design, pre-RFP, included in as information to the design build bidders and allowing them to move forward with a 30% design that they are bidding on in the RFP process. so that they can then move into final design. But it also allows the agency to maybe take on some early relocation considerations that may be long lead time, that may impact a design build contractor's schedule. But they, it's hard to convey that to them until they actually have gone through the RFP process. And by then it may even be too late to give them an edge up on a long lead time relocation. So there's just things like that maybe the agency can handle and spell that out in the RFP before bidders come on. It also can be done through standard utility agreements. And again, that's just some of the advantages of maybe having early relocations and design build, but only to allow these long lead time relocations. I'm talking like transmission lines, big overhead lines that take years to coordinate and relocate. And it could really hinder the design build team if they had to start that from scratch the day they walk onto the job. So that's really what we're trying to emphasize here. They're not common for design build, but there are instances where we would take that on and then spell that out in the RFP so that the contractors or the design build teams know about it. Again, this is a utility coordination effort. And then utility schedules and relocation schedules obviously are extremely important in building these. And then some of the items that we want to really focus on when building a schedule, obviously size of the utility, critical utility, time of year. So the large gas line, you're typically going to want to relocate it in the summer, not during the winter when gas volumes are up. Same with irrigation. You want to relocate them in the winter when water's out of their irrigation facility and not in the middle of the summer when they're running full flow. And so building schedules that include this kind of information is extremely important because it helps with phasing this information into the ultimate schedule for the construction project as a whole. So we don't want this to be a standalone, built in a silo type schedule. It needs to be conveyed to the project team and those building the bigger schedule for construction, so that we can identify any early critical path items from the utility side that maybe we need to accelerate or move, find a way to move them to the head of the line. So when we look at final utility specification, we're at this 90% approaching the FOR. We're starting to really finalize the work plan document, maybe even finalized it and starting to move into utility relocations and incorporating that into the final spec. But within that final spec, the description of the utility work, special conditions that they may have or need, time expected for completion of the work and dates, anticipated dates of that utility work. Required amount of advance notice is important to the contractor because some utility companies need 30, 45 days notice before they can even make it out on site and start their work. So that's critical that the contractors have an accurate account for the timeframes. Any instructions, disclaimers, special information, all should be wrapped up in this final spec. So this concludes the 30 to 90% design phase module of our CDOT Utilities Process Management. The next module in the course examines the 90 to 100% design phase. However, before we take off, here are some key points to remember. By the end of this 30 to 90% phase, the plans, the coordination, contracts, all this stuff, there's a lot that's gone on between 30 and 90% from SUE, quality level A, the conflict matrix, contracting, work plans. All this stuff has been developed, so you've gone quite a ways from 30 to 90 in order to get to this final spec package and the project to a point where you're just getting through 90% and you're finalizing any loose ends from the design side. But from the utility side, you should be, rather solid on where we're at and where we're headed towards construction. Thank you. We appreciate your time today.